Hey guys, welcome to Bar Z. My name's Stan, and welcome to part 2 of Sine My Grind. And as you can see here behind me, we've got our sine plate attached to the table. It's been seated, and I'm going to go through everything I did to make the hold down brackets. You guys already saw me grind the table. We're going to measure the top before we regrind it and make sure we're getting the same numbers or reasonably close. We're gonna go over the top of the table, and then I'm gonna tram it down the long axis to the table and get it as close as I can. The sides are actually a little wavy, so we're gonna tram the table and get it very close so there's very little to grind off, and then we're gonna grind the top, the front edge, and the back edge both. So we're gonna grind all three sides so they're all parallel with each other, because I use you can use a fence on the back or on the front, and I use those as points of reference to square parts on it. So I do want my front and back parallel. So let's get to it. Let's go look at some of the footage of getting this thing fitted. Okay, and we got our sine plate just laying on there, and you can see we've got the table painted. Just the top. I'm not repainting the whole machine. I'm just doing it for rust. And I actually found a use for this. This is Steel It anti-rust stainless steel in a can. A gift from Tom Lipton when I was up there visiting him quite some time ago. So I found a home for a little bit of that material. As you can see, the sine plate fits down on the table very nicely. It's a good fit all the way across. What doesn't fit well is the clamps, and I'm going to kind of show you what we intend to do. Out here in the front, I guess that's the front, maybe the left, we'll call that the left. On the left side, all we've got is 2 tapped holes, no really good way to clamp except maybe up on top here. And the factory type clamp, I know I showed you these before in the other video, but the factory type clamp has got 2 ears on it, and it'll pinch in there pretty well. The only thing is it doesn't really sit too flat, so I'm going to make a little riser block here for the back and be able to pinch that down, and it won't affect the sine plate at all. It looks like it's going to grab it really well and pin it down in two places, because it's got the 2 fingers going in. So I'm going to make a little riser block for this back, and then I don't even have to modify the clamp. Now the right side of it is a completely different story. That's only going to be kind of a single point mount, and this one's only got this little groove right here. That's a 3/8 groove, and so it's going to be like a finger type clamp going in there, and I'll just make that from scratch. So the sine plate will have a 3-point mount, center, and then the 2 others on the other side. So that's what's going to pin down the plate. So I'm just going to make this clamp from scratch. I'm not going to modify the factory ones. I didn't really want to modify those. Those are too nice to start carving up. All right, so we've got a chicken scratch drawing. We're just kind of making an L-shaped piece. I've already milled 3 sides, and I've measured my plate, and I've got 350. That little slot is 375, so I'm making the tab 350 so it slides in there with no binding. And I've measured from the bottom of my mounting pad up to the bottom of that slot, and it measures actually 330. So I'm going to make it 335, just a tad taller, just so it slightly tilts up and it gets a good pinch out at the nose of the thing. So that's just a quick shot chicken scratch, but those 2 put together is 685, and I'm starting off here with a 1-inch block, so we got a long ways to go. I'm just going to grab a temp gun here and see what our part is, just for the heck of it. I'm cutting this stuff dry, no coolant, no nothing. I didn't feel like setting the emissive setting in here. I compared it to I got a shiny surface, I compared it to the vise and just used it comparatively, and the part is about 3 degrees hotter than this vise jaw. So I'm still doing good. I'm pretty happy so far. Yeah, this thing is just barely warm. The trick is to push your carbide hard, and when you start seeing these color chips coming off of it, these nice blue chips coming off like this, you're actually pulling the heat away from the part. The chips are getting hot, the part is not. Alright, I'm going to take another 5 thousandths at the same speed, and we're going to be about 10 thousandths off of our mark. Okay, so we got, let's see here. I set the mic on bias. We're looking for 0.685. We're 10.7 over. So let's come up, just come up our 10 and bring it all the way in. There's your 10 thou right there. I'm actually going to speed up the machine slightly. I'm running about 500 RPM right now on a 3-inch cutter. I'm going to go ahead and take it up to about 650 and slow the feed down just a tad. If you slow it down too much, it'll get kind of smeary on you, but that's a pretty good feed right there. So I'll bring you over and let you look at that finish. So same insert did all the roughing and did the finish work. Not too shabby. Now let's see where we're at on size. And it looks like we're within 5/10. I'm pretty happy there. That's just the height of it. I want it to be 10 thousandths higher than that ledge, so it pinches down at an angle. So 5/10 I'm happy with. Plus the part's a little warm. She'll cool down, and what are the odds we'll get it right and it'll just fall right into spec right as it cools? Wouldn't that be awesome? Okay. Okay, so we're gonna make the 3/4 notch in the side where it makes the step. I got a lot of material to remove, so I'm just gonna make multiple passes with a corn cob, also known as a roughing mill. And we're just gonna get it spinning the right way. And I've got a limit line on there, and I want to stop short because I want to leave room for a machining allowance for a finish cut. And I'm just gonna bring the table up just till I start touching here. I hear something going on there. There we go. And I'm going to zero my dial. And on the step, we're taking out 335. So maybe we'll just take it up to 300 and hog all this material out. right at 300. So I'm just going to go one revolution, that's 100, 200, 300, lock the table, and I need to get my side to side set and turn my feed way down. I've got some watered down anchor lube, which is a pretty good coolant alternative. It's not terrible. Let's engage this feed and see how we do. Okay, so for whatever reason the GoPro decided to shut off in the middle of all that. I don't know at what point it shut off, but it shut off nonetheless. So we've got our rough milling done. I mean, we're going to take it out, measure it, deburr it, get all this nasty crap out of here. And we've got all the crappy work done. And those, I think I'm due for a new roughing mill. My chips are turning colors there, which is not a great thing for high-speed steel or cobalt, either one. I think that's like a 5% roughing mill. So I think that roughing mill's had it. I don't think those can be sharpened. I think when they're dead. So let's get it cleaned up, get it measured, figure out what we need to do. We need to, we left a machining allowance on this width, and we left a machining allowance on this face, so, because we still need to mill some of this down. So let's get it all cleaned up and get it back in, and I almost forgot to turn the camera on. Okay, we're going to bring in the thickness of this block down to size. It's going down to 750. And we're still 27 thousandths big. I'm going to take my zero down to 0 here. There. Okay, so you see it's got a little step down. I was taking it down to depth. This where we rough milled is still 29 thousandths thick. So next up, we're actually gonna do a round over on this right here with a round over mill, and then we're just gonna come back and face mill this and get this down to size. But right here is 29 thousandths thick. Okay, so we got our little roll done, sine roll, whatever you want to call it, but that's the back of the clamp, and that's gonna let the clamp roll into the sine plate and hang on to it. We still got 29 thousandths to take out of this, so and I got to start over because we were busy with this stuff. So I had to change tools, so we got to come back, touch off again, and get that 29 out of there. I'm just going to come back and do a quick touch off. And probably just make a little tiny pass, measure it, and then start again. Right, so there's a little bit. I got 24 thousandths to go. 24.4. We're gonna go 10, maybe 20, and then we 4 thousandths for a cleanup pass. Yeah, we do. That's what we're doing there. Showing 3.9 out. Yeah, that's still about 4 thousandths thick. And at this point now, I'm going to run the machine and get it all the way into that corner. So I'm machining all the way up to that edge before I raise the table, and that final pass will just be one clean sweep. Okay, that's it for a final. Let's give it one final measure. But I think we're going to be adequate there. Oh yeah. We are good. All right. So that's what the profile of our little clamp looks like. And see, this enables us to put our bolt out here, and the flat spot on the bottom of the clamp doesn't influence the clamp at all. When we tighten the bolt, it rolls into the part and clamps it securely. So that was my reasoning behind putting that little radius on there. All right, there's another good look at it. All right. So to replicate the that curve, I just did it trial and error, made a cardboard template till the template fit in good, and I was using the compass to draw on the cardboard. And then after I found a winner, didn't change the compass, and figured out my back spacing off my center line, scribed a line, very little to remove. Just gonna bandsaw the corners and belt sand it to fit, and that's what's gonna drop into that sine plate. Not high tech, but nice and quick. So our clamp's done. We've got the top radiused, and we gave it a deburr and a quick polish just to clean it up. So there's your profile. And I played around with the hole spacing, and what I was trying to do was make sure that the nut and washer setup on here isn't going to interfere with the plate when it tilts. So I'm able to make 47 degrees with the nut, bolt, washer, everything there. So all I really have to do is make 45, and I'm a pretty happy boy. And if push came to shove, I'll show you what else I can do. We'll drop this in real quick. This index is in there, and this plate sits really flat. It's got a slight tilt towards the vise, which is what I wanted. I made this the roll back here 10 thousandths higher, so it tipped up a little bit and pinched in towards the vise. So when this clamps down, the first thing that the sine plate's going to want to hit is that piece of stud sticking up. And it does it right at 47 degrees. So I'm okay with that because all I got to do is make 45. But if push came to shove, I could always trim that stud down. So let me get you in a little lower here. You can kind of see that profile of how that thing lays in there and how it clamps. So that's the back clamp. And that was a complicated one. The front clamp is a lot easier. Basically, that's just a piece of flat bar. This is another piece of 4140. I'm just going to mill it parallel on each side and put a ball groove down the center for this radius to sit in. And we're gonna end up with our clamp essentially flat, just tipped up this way, just 10 thousandths, just so it pinches in on the plate first and doesn't try to, spit it out. So just giving it a 10 thousandths lead-in angle. So this one's 10. I don't know, you probably can't see it, but it's tilted in this way, 10 thousandths, and this is going to be the same thing. So this is our next piece we're going to make, and it's just going to be a supplemental piece that goes on to this existing one. And then this thing is clamped, and we're ready to bolt it, pin it down, indicate it, get it all squared up on there. So that's the next step. Okay, so now we're figuring out, we're going to move to this other side, and I just got a little gauge block stack here, and I'm figuring out the angle of my clamp. And this was, I'm just kind of going off the top of the casting, and I'm looking down here at the tips of the fingers that go in on the sine plate. And I've come up with 312 thousandths, 0.312, which is right at 5/16. So I'm going to make the my little block. I'm going to make it thick, but then I'm going to mill a little ball groove in it. If you look at this clamp, this has the same rounded base as the other one we just made. So I'm going to give it a little ball groove for it to sit down into. And I'm going to go ahead and mill it all the way across. I'm not going to make it a pocket because if coolant gets in there, it'll trap it. So I'm going to actually mill it all the way across. So let's go do that. Okay, and we're bolted down. I haven't done any tramming or anything yet. This is just the very first time I've tightened these clamps, but I know the bottom of my plate is clean. I know my T-bolt isn't long enough, and I need to get a longer one so I can get a washer on it. And that's my little adapter thing there with the ball groove in it, and a real simple piece to make. And we're seated down. We've got we've already trammed it. We're clamped for the last time. We're happy with everything, and we're going to do one final check and see what kind of numbers we're coming up with here. And I'm trying to work around the camera and run this thing at the same time. Okay, I'm going to pull up. You're going to see I've got 1,000th of preload on this thing. And I'm going to try to tap it in and get her to settle in at 0 there, which I'm a tad below. Let me give it one little tick down here. See if she settles in there. And it's a 10th high now. Fussy. See what that does. Alright, we're going to call that a good 0. And this is actually where it all began, right back there on the surface plate. That was my first measurement. That was 0. And I don't know whether you can read my numbers. I've still got my felt pin numbers from the surface plate. But I'm going to take us over here. And over here I was getting a 0.2 on the surface plate. Here I'm getting a 0.1. Over here I've got a 0.4 on the surface plate. I'm getting a 0.4 here. Let's go the other way. I was getting a 0.1 on the surface plate. I'm getting a 0.1 here. I was getting a I was getting a 0.6 on the surface plate. Okay, and here I'm getting a 0.4. So this is a little lower, and some of these can be attributed to us actually clamping the sine plate down, or now we're actually forcing it down onto the table. So some of these numbers can be attributed to that. Let's go back to the center and run out to the middle and see how we're doing out in the middle here. And there was an interesting question on the channel on whether I cleaned my sine roll and the plate that the sine roll sits on it. And yes, I did. I cleaned both of those very thoroughly before we took these initial measurements on the surface plate. Okay, so we're out in the center. I'm on 0. Let's go over here. This was a 0.2 on the surface plate, and I'm measuring 0.2. This was a 0.4 on the surface plate, and now I am measuring 0.6, so that's very different. But still within a couple of tenths. Over here we're 0.2 on the surface plate, and I'm not even 0.1 indicated here. All right, let's go over here. This was 0.4 on the surface plate, and 0.4 indicated. So let's run back to 0 here. And we'll go ahead and run all the way up to the front. Bumped it into a stop there. Let's get it off that stop. Yeah, it's causing some backlash. Okay, I'm showing minus, about 3/10 there. Let's run over here. Positive 0.1. Surface plate was positive 0.1, so that actually coincides. This was a positive 0.2 on the surface plate, and I've almost got 8. I'm sitting at 8/10 there, so that's very high right there. And see, I can't get that sucker to move at all. I'm not getting any needle moving. I'm pushing down hard on that sucker. So yeah, I thought maybe I got a hair or something under the sine roll, but no, I don't. All right, let's run over here. This was a 0.1 on the surface plate. This is a 0 here, so that's within a 1/10. And then we're going to come up here. This was a 0.2 on the surface plate, and I'm showing a good solid 0.5. So I've got a couple of numbers that are kind of popping up kind of high. Nothing too alarming. I think we're seated good. I did tram it across the back, and I'm within a 1/2 thou from this edge to that edge. And actually the back of it is kind of hourglass shaped, so it takes a bad dip and then comes back up down this back edge. But we're going to regrind that. I've got it as close as I can possibly get it, and to save myself some grinding and get it as parallel as possible right out of the gate. But I think we've got a good base to start grinding on this. And here you'll see after the first grind, that's a touch off and about a 1/2 thou down feed. And you can see our zeros were up the center and we were high on the ends. So she was kind of sway back. And there's a lot of scratches and dings and stuff in there that would be nice to get out of there anyway. So we're going to keep going, maybe another couple thou, you know, we're going to just do half thou at a time. But this thing looks like it's going to clean up real nice and real easy. I got you a decent camera angle, and I'm hoping there's no glare on that. And here we are, 1,000th preload, always as before. I'm going to try to get it to stay on 0 and bumpity bump. Yeah, it's going to bounce around there on me. Let's try this. Okay. See how we do there. I'm just going to run from the back to the front. See if it stays at 0. Okay, we're all the way out the front of the table, and it's not even a tenth. It's kind of split in a tenth there. Let me get this thing in motion. Yeah, there she's a tenth below there. So I've got a tenth of error from front to back. I'm going to crank it all the way to the right here, and still tenth below. Right on 0 there. Right on 0 there. I'm just letting it settle back in. Right on 0 there. Tad above there. So between here and here, I got about a total of a tenth of error. Let's go out to the middle here. Now here we're about 2/10, so I worked a dish into it somehow, some way. And coming out to the end, we're coming up on 0. And if you remember, this mag was sway back. It had a dish in it to begin with, so it's like it keeps wanting to take that kind of a set. So this may take a couple of grinds, and I need to keep an eye on this chuck for the next couple of weeks. And measure it frequently, you know, and maybe give it a regrind. There's a tenth below. We're out in the middle again, settling in. And it's at about a tenth. So it's definitely a sway back, and that's the way it wants to take a set. That's the way it came to me, and it's even after a grind, it took that kind of a set when I released the surface tension or whatever you want to call it there. And I'm grinding everything with the magnet on. I haven't turned the magnet off since I started this stunt. Alright, we're back in the beginning, and we're back at our 0. And we're just going to zip over this way. So there we stayed at 0 back there. And we stayed at 0 there. So total variation front to back about a tenth. Variation out here on the front of the table is about a tenth between here and here. So there's a little something going on out here. And like I say, I'm going to keep an eye on this plate. I'm sure it's going to wiggle its way in a little more and get out of whack a couple more times, and it'll take a couple more grinds to get it to grind and stay there. So that's pretty much a wrap for this. That's the top of the table. I'm going to grind the back, and I got to actually make a fence for the back of this thing. So, but that's installing a sine plate on a surface grinder. So we've got the top of our mag done, And I'm going to try to get you in back here to see the back and try to get an angle where you can see the grind on the back. I don't know if you can see it with the light, available light. Well, let me hit this one, maybe that'll light it up. No, that'll just blind the camera. But this this beam here in the back's been ground, and it's within 1/10 side to side. So this is running real true to the axis of the table. And this was just a garbage wheel. I was getting ready to throw this thing in the trash, but I was able to trim it down and get low enough to get back there and get the back of that of the mag ground. You know, usually a cup wheel is pretty big, and this one was all worn out. And you know, I'm only maybe 30 thousandths from hitting that arbor and that nut, but I was still able to get in there and make that cut across the back. And I got to play with my new angle dresser, so that was awesome. Got to play with that. So I got it set there for a 5-degree angle, so that was pretty cool. And yeah, this thing's at a close. I'm gonna give this about another week and give this top another grind, let everything kind of settle in, and I want to get some use on it and let everything vibrate and wiggle in, and then check the top again. But we're going to be keeping our eye on the on that top plate for the next few weeks. Alrighty, but this project's at a close. Thanks for watching, guys.